geometry.
This meeting is being
I don't
recorded.
know how that happens, but it happens.
Okay, so but you know the problem on which you didn't get the
Yeah,
full points.
I got like 24 out of 25 on the
Yes.
Uh,
geometry. I don't know
If
why. I still don't know why.
well, if you were in California, I know that teachers they reduce the points for insufficient reasoning. So it may be everything is good, everything is correct, but reasoning is insufficient. So maybe
which is
some logical gaps between
which is
statements.
perfectly correct and okay for math competitions, because the main part is reasoning, and of course the jury did check all the reasoning, but I don't understand how one can earn 24 out of 25. I mean, what is 1/25 of a problem, of a solution? Because I'm used to 7 points. I mean, we had 7 points in all competitions.
The answer was
Rarely
not
four.
boxed or something like this.
Okay, so let's proceed. We're all here.
Yeah,
That is
okay, okay.
good.
Okay, by the way, I didn't see any solutions for the game of life problem. So let's postpone it to probably the next lesson. So today, if everyone's okay, so Vladimir had shared with me the problems for the previous year, for the previous Olympiad. So I wonder,
And
do
answering
you
your
already
question, no,
went?
I did not discuss these problems with the team.
So let's do, because there is some simple primitive machine learning stuff, and this is very nice to go through all the problems. As far as I understand, the problem scope is not for 1 hour, definitely, but so we are not going to solve it precisely one by one, but definitely we can discuss it together. So today there will be not a lecture, but kind of a seminar, and please do the homework for the game of life. I want to add one more comment. So I am 100% agree with you when you are saying that debugging someone's buggy code is much harder than writing your own code that will be clean, that will be good, that would be awesome. This is 100% true. Uh, just one thing. So if you are able, if you are capable to debug someone's code, if you can find the mistake in someone's code that is not written by you, this is a great opportunity. So if you can find someone's mistake, you can definitely find your own mistake. That's why it is important to practicing reviewing, fixing someone's code. It helps you build your own code more clearly. So definitely, if you want to write down your own code for the game of life with, I don't know how it's called, red and blue warriors, and they fight each other and they disappear if they are occurred on the same cells, feel free. That's okay. But if you may spend maybe an hour, maybe couple of hours to find out what's going on in my buggy code, it would be great. So it will, how to say, the result will be not as visible as if you are writing your own code, but the result is invisible, like you are doing the PE, the weightlifting fitness. So the result is in the future. So that's why this is important. Please do this. So this is important even if you don't see the result. You just write in someone's buggy code and then why this is done so ugly. So I could do it better. That's okay. That's true. But if you can do it, that's great. So okay, personally myself in the software development for the last uh 34 years, 3 4. So yeah, So probably I have some experience in this. So yeah, probably this is important. Okay, so please do the game of life for the next. And today there will be kind of a seminar. So let me share my screen for the problems of the previous lesson. Definitely, I believe so. Oh, by the way, some of the problems are mathematical problems. So I'm not sure whether you should go over the mathematical problems, but anyway, so last year there was some. So a lot of people were crazy about COVID. So now there are some other topics to get crazy on, but that's okay. That usually happens. Uh, okay, so let's start with the junior and then we will get to senior. Please, guys, please let me know if this is oversimplified. If you can say, wow, why should I do this? This is a table of multiplication, so nothing special. That's okay. Please let me know and we will go to other problems. Okay, do you see my screen? So this is a pandemics over networks.
Yeah.
Hello. Okay, good. So a new virus called Duovid. Okay, it's not COVID, it's a different. It's spreading among human population rapidly, and it spreads in a very unique way. Whenever someone gets in touch with two or more infected people, this person becomes infected by it as well. So you can probably see some similarity with this problem and the game of life problem. I hope so. And unfortunately, the infected person will remain infections even after recovery. This challenge is tackled COVID spreading in different societies. So, as you remember, for the game of life situation, there was a square lattice and the connections were so every cell has 8 connections. So diagonal connections are also connections. Okay. In a place called the Triangular Village, the villagers has a very strict way of interactions. They are only in contact with each other on a triangular lattice. Okay, and here it is shown. For example, person A, bottom node, is only in contact with B and C, such when the contact B and C are infected with COVID. So A will get infected. There are 15 people. So you see that there are 3 types of people. There are corner people, that are age people, okay, vertex people, age people, and face people, kind of. So for vertex person, there are 2 connections. For age person, there is 1, 2, 3, 4 connections. And for the face connection, there are 6. Okay, 1, 4, 6. Okay, so there are total 15 people in the village. Okay, so here you are.
Sorry, just a question.
Yeah.
Uh, is there a way for us to get the problem? Because personally, for me, it would be easier to follow along if I could read the problem on my phone or something. If you could just send us the
I'll
link
send it.
or where to
Oh,
find.
yeah. I would ask Vladimir, could you please send
Yes, I
this
can
paper?
Thank
send
you.
it in Telegram.
Okay, yeah. So it will be there. So okay, so let's start with a simple problem. Question 1A is just a warm-up. The villagers are worried. People are usually worried that even with several people initially carrying the virus, Duovid may spread to the whole village. What is the minimal number of initially infected people or nodes such that Duovid will spread the whole triangular village? Let me tell one more time. Where is it? It is when whether someone gets in touch with 2 or more infected people, this person becomes infected as well. So for example, if B and C are infected, then A is infected again. Yeah, and after A, this guy is infected. I don't know whether you see my mouse. I hope so. So
Yeah.
these are infected, and then this is infected. Okay, so uh, uh, so the question is to um okay, so but if B is infected here and C is infected here, then there is no spread. So what's the answer? Could you please?
Yeah, what? I mean, two. It's enough for B and C to be infected, so it could all spread.
Okay, yeah. So if B and C are infected, then the entire village is infected too. Let me ask you one more question. If B and C, for example, if B is here and C is not C, it is X. Okay? So then this guy is also infected and everyone infected. Imagine B and C are far away from each other. For example, B and C occupy this vertex and this vertex. Then no one is infected. So could you please give me the number? But for example, if the three vertices are infected, then no one is infected. So to infect the entire village, the infected person should be close to each other. So there should be at least one person that is. So there should be at least one infection, additional infection. If the step is this, then no infected. So this is actually, okay, Marka, if you know math, so you can probably know about how to color the graph. So you have the graph and you should color it into three or maybe two colors or maybe four. So how can we color the graph to understand and what's about if how to say the minimal number and zero means that if you randomly put the infected person on this triangular village, all the village will be definitely infected,
Yeah,
regardless of what are the
then,
position. Do you
yeah.
understand my question?
I understand now.
Okay, good. So the correct answer is not two, because two
Yeah, I know that
is
it's not two, but I didn't understand the question well. Yeah, first
uh-huh.
time, so yeah.
Okay, so it means what's the minimal number? How to say? If you put these two nodes next by each other, so they are SBC, yes, then it's okay. But if you put B here and C, for example, here, the village is not infected. So there is a possibility if you put two infected persons in the village and the village is not infected. But the question here is. Regardless of their positions, what should be the minimal number for the people to get infected, or what is the minimal number of infected persons for this village to remain not infected? Does that make sense?
Yep.
Okay, let's start with L equals to 1. Uh, by the way, I
Is the
don't
answer
know.
6?
For L equals to 1? For L equals to 1, the answer is definitely 1, because this is only one node. L is by the way, I wonder why this length is 4. Actually, this length is 5. So where here L is not 4. Here L is 5. There's
L
1,
is the
2.
number of edges.
Okay, L.
Mm.
Okay, let it be ages. Okay, let's start then with L is equals to 0. Um, by the way, can I share somehow the do we have the whiteboard here?
Of course.
Probably. Do you know how to
Unfortunately,
use it?
you cannot share both your screen and the whiteboard simultaneously.
Okay, no
Uh,
problem. Let me share my
uh,
whiteboard. But how
wait,
can I?
wait. You can wait. You can write on the screen right now. Do you,
Really?
uh,
I
look,
cannot.
there are several. Let me show you. Okay, just
Yes, please. Yeah, yeah, yeah.
like 3 minutes introduction to Zoom
To Zoom.
features. Yeah. One of the options is to turn on commenting.
What is it?
Okay, just a second. Annotation. Looking for it, cannot find it because usually it was very strange. Reaction. I can share my screen, but that is not what I want to do.
That
Whiteboards. Oh, okay.
probably there's a you can share your screen and allow other people to write on your screen. That will also work if you wanted to.
I don't get it because everything was a bit different. Captions. Uh, okay, let's check if you have this option. Uh, do you have somewhere near the screen sharing? Do you have something like annotation, annotating, or commenting?
No, I don't. I have participants, screen share, chat, record, show captions, AI companion. Okay, that's great that I have the AI here, but that wouldn't help. Let me probably install Punto. So, or Pinta, I don't remember how it's called. Okay, come on. So we will use the straightforward way of drawing pictures. I just Pinta. Whether it works? It is. Can you see this awesome interface?
Yes.
That's great.
Now
Now I can draw.
I see you
Okay.
pointed in Zoom.
Yeah, that's okay. I believe if you pay a lot of money for them, they will allow you to draw pictures.
No, it
Problem.
wasn't that, and I am paying them.
Okay. So you're paying them. You're paying them not too much, I believe. So that's
Not
okay.
enough, yeah.
Not enough. Not sufficient. You know, it's like the autonomous vehicles. You should buy the subscription. So then it will drive by itself. If you don't buy the subscription, it's your responsibility. Okay, whatever. Uh, let me draw. Let's start with this, by the way. So this is L equals to. Okay, if it is ages, if this is L equals to 2. So how many nodes should be infected? What is the minimal numbers of nodes to get infected for everyone to be infected?
3.
What's the answer?
There's no way, guys.
2. 2.
2 is enough, yeah. 2 is
2.
2. Okay, so you select, for example, these two nodes. This is infected, and if, by the way, the first thing that we can notice that if you select the two nodes that are nearby, this makes everyone infected because this is this, then this, then this, then that. Okay, very good. So, what's about 4? 3, 4. how many nodes is enough, is sufficient to infect everyone?
I guess now it's 4.
It is 4, correct. How can you prove it? So let's write down here L equals to 1, 2, 3, and the answer is 2. If L is 4, the answer is 4. Okay. So 4 is definitely you, for example, you select those two and you can select any and it will be infected. Okay, so let's try to find out the answer for 5 and for n. There will be 5, 6, 7. Okay, so 1, 2, 3, 4, 5. Okay, let's pretend that these guys are not infected. 1, 2, 3, 4, 5. Okay. Let's start do the following. Imagine a node is infected. How far should be the node not to, how to say, not to infect the entire region? So
Yeah,
it
they
should
can't have the same
definitely,
neighbor.
yeah, it should definitely be beyond this, right? Okay, so if we infect any of these 4 nodes, that would be okay. Okay? Okay. So how many? Is it 4? If we select this and this, yeah. So here are the regions of interest. So in every region of interest, there should be only one node that is infected. If there are 2 nodes that are infected in the region of interest, oh, we are in a trouble, right? Okay, so the question is the region of interest is a triangle? No, definitely not. Yeah. So the region of interest is a hexagon. So for example, if I take the node of being infected this, so there will be a hexagon like this. If any other node in this hexagon, they're infected. Okay, so now we know some math here. Okay, so what is, this is 5, what is if 6? 1, 2, 3, 4, 5, 6. So for 5, it is also 4. Yeah. Okay, so what's about 6? Please give me the answer here. Hello? Any ideas? So not the answer, ideas. So let's, for example, start doing this. So what should be the answer here? So this is a problem on tiling. Problem.
Yes, 5 now.
5, correct. So if I take any node that is here, for example, yeah. So I will, for 6, it is 5. Okay, very good. For 7. Wow, Here is a problem for 4. We know this problem. We already solved this problem, right? This is the problem for 4. Oh, I'm sorry, for 3. So if this is ages, so this is a 3 problem. What is the solution of the 3 problem? Okay. Who can build the recursive, probably recursive solution, or it is not a recursive? So if it is 1, 2, 3, and the solution for 3. The solution for 3 is 3. 1, 2, 3, 4, 5, 6, 7. Okay. Hello. Is anyone here? Okay. Yeah. Unfortunately, I cannot ask you to write down here. Okay. Now, right. Okay. Let's continue.
Just one question. My Wi-Fi is
Yes.
sort of bad, so I didn't understand properly. So we're looking for the least amount of infected people in order for them to infect the whole village, right?
Yes, that's true, with one comment. This least amount of infected, uh we can put this amount of infected people on any places
Okay,
in
yeah,
the
randomly
village.
distributed.
Yeah,
Yeah, okay.
randomly distributed.
Okay,
Yes, and
perfect.
we should make sure that they will be infected. If we put them precisely, then there will be answer 2 for any number. Because if you just put 2 infected people
Yeah,
next to each other, they will
next to each other,
infect the
yeah.
entire. They will infect the entire village, regardless of its size.
Yeah, okay. Thank you.
So that's why the problem is okay. Actually, this is the problem 1C. What is the maximal number of people infected such that it would not result in total infection of the village? So this is for this problem, and we already have solved this problem. One day a village obtain as okay. Instead of village length is 4 shown there. Suppose L can be any positive number. What will be the answers for question 1A and 1B? Combination of counting principles could be helpful. Okay, let's try to answer the question 1B. If we know that there are exactly n nodes infected, where a node is solution from the previous question, but each infected node is a random person with the same probability, what is the chance that the whole village will be infected? Let's reframe the question in the following way. So as Nina just mentioned, if we okay, so for example, this is the village with L equals to 3. Okay, what is the probability of the village to get infected in case of 2 random nodes are infected? Does it make sense? Hello? So we
So
infect
two nodes are infected and
yeah. So we infect 2 random nodes. For example, this and this. Is the village infected? No. We infect 2 other random nodes. This and this. Is the village infected? Yes.
Yes.
Okay, what's the probability if I mark 2 random nodes as infected? What is the probability of the village to be infected? Let's count the nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, so we need to
Okay,
count the number of pairs
that's
of
correct.
nodes
What is
we
the
what?
good. What is the number of pairs? What is the
Of
total
pairs
number of
with
pairs?
same neighbor that have same neighbor.
No. What is the total number of pairs here? What is the if we
45.
have 45, correct. Uh, okay, 45 number of pairs. It means that 45 is the pair, for example, pair 1, 7 is the same as pair 7, 1. Does that make sense? So this is the same pair. Then the total number of pairs is 45. How many of these pairs are infected or maybe not infected?
I mean, for every node, it's all those that he's neighboring with, and every single one that there is just one in between them. So
That's
just
correct. That's correct. Oh, sorry. So how many, or what is simpler to calculate, the number of infected pairs or not infected? I mean, okay, so for the
Not
guy
infected.
number,
you're probably not
not
infected.
not
Yeah.
infected. Okay, great. If there is if one of the person is this one, okay, how many pairs with one that are not infected? So this is 1, 2,
4.
3, 4. Okay, very good. So 4. Let's take 2. How many?
Only 1.
Only 1. Okay, let's take 3.
Same for like for 2.
Same
It
for 2.
it
Okay.
depends if it's edge or central if
Correct.
we calculate
And we should not yes, this is true, and we should not count the numbers that are less than current. So for 1 this is 4, for 2 it is 1, for 3 it is how many? Or for 2 it is not 1. For 2, for 3 it is 1. How many for 4? If we can count only downstairs, it is 0, 0, 0. But for 7, how many? 1 is already counted.
So 3. No, only 1. 7 and 10.
Only 1. That's very good. Let's write down the pairs. 1,
We
4.
could calculated it like
Yeah.
all from each point to select the pair and then divide it by 2. So we remove all the same pairs. I think doesn't matter.
But
For L3, it doesn't
sometimes
matter.
by 2, sometimes by 3.
Yes.
Okay, we can
Yeah.
so by how much should we divide it?
Let's continue like this and
Okay, let's continue like this. For 2, what are the answers? it is 10. Okay, for 3, it is 7. For 4, it is 10. For 6, it is 7. And for 7, it is 10. Did I miss anything? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is 1/5. Not to get infected. So the to get infected, it is 80%. Does it make sense?
Yes.
Hello? Okay. Very good. Very good. Can you write a program that proves this fact? How can we? Let me open a collab and share it with you, and please write this program. Oh, okay. No, let's not do this. Let's do the program in the next stuff. Okay. So there is another place, square village. The villages only interact over a square letters as shown in this figure. There are total 16 people. What is the minimal number of initially infected people that can spread to the whole village? But here is, let me ask the question is in the following way. So you can you want to spread this infection. So whom should you infect? What is the minimal number? Not minimal, not in terms of randomly infected, but precisely infected. So you want to infect someone. So whom should you infect to infect the entire? Whom
I
should
guess
you
it's
infect?
only two
Yeah,
again. You can
that's
infect
correct.
just zero,
Yeah,
zero, and 1, 1.
0, 0, and 1, 1. Yes, and you infect this, and then you infect all these guys. Okay. It's interesting that they say that answer is different. Why the answer is different? It's the same. I don't understand.
It's
Okay.
not. So it's not two.
Yeah, what
Why
do you
not
mean,
2?
like 4 or?
And is the answer not two, or is it two?
Why is N0 in the square village different from the triangular village? Actually, I don't understand. Have no idea. Okay, spreading, modeling, machine learning. Oh, let's do machine learning. The virus has reached a community with a complex content network structure as here 3 people are infected, yet 0 and 1 are identified with the other. The network structures content the contact age list. Note that non-computer program are accepted, but only partial credit will be given in this case. For computer program solution, you need to use the Python library. Network X. I have no idea what is this library. Does anyone? There is some. Come on. Why so slow? Okay,
I guess
anyway,
it's just a graph library or something like that.
yeah, kind of. I see the community comes you to help to understand what is the worst case scenario and what is the most number of people that can get infected. You write a Python program to model the spreading given any third infected person and calculate the final number of infected person among the community. I wonder what is yes. So there is a contact age list that is given. Okay, so we can probably create the random one. If the third infected person is one, the right more or less spread given any third infected person, calculate the final number of infected people among the community. For example, if the third infected person is one, then the word will stop spreading immediately, and 3 persons are infected until the end. What is the highest number of infected people possible? Interesting. Good question. Let us do this modeling. Okay, let's. Thank you so much. So ChatGPT is not good today. So probably this is because of the wrong browser. How can help me? Okay, nice. Thank you very much. Great. Great. Okay, now I probably need to generate a random graph. Can you help me?
Do you want sparse graph or just a random graph?
I good graph. Good graph for that modeling. Define. What does it mean?
Yeah, it's function in Python. That's
Okay,
that
so what
much.
should I do? Okay, let's start with this, right?
I guess the easiest way is just to make matrix, fill it with ones and zeros, and then convert that into edges. I mean,
Write the
we
code.
want here adjacency list here.
Okay, metrics or ages or you mean this? Or how?
I mean, you can do that and then just go from place to place and put something random, one or zero.
Mm-hmm.
That will give you something random. Really
Let me
random.
ask this guy. Mm-hmm. Already done. How many? Okay, 70.
Okay, so there is a function that generates random graph in Python already implemented, or
Correct.
oh,
So this is the good example. Please don't do things that are already done. Oh, n is not defined. You are not so good. Yeah, you see?
what do you mean by not so good? It gave you a graph.
It doesn't look like this. I want something like this.
Oh, you're saying that there are too many
But
edges.
this one doesn't have 70 vertices, I believe, on the picture.
Okay. Now I want to connect. So how can I connect these two bars of graph? Okay, enough. Oh, very good graph. Okay, so now I want to mark two infected. Okay,
Is there a way to add like some argument that you want to connect the graph?
to connect the graph.
I mean, is there a way to always generate?
Is there a way to get the random generated graph? I don't remember the English term.
It's connectedness.
Yeah.
Uh, I believe that the threshold value is 1 over n minus 1.
Yes, of course, but we are working in probability way.
Yeah, way larger than 1 over n minus 1.
Uh-huh.
Okay, so you're just gonna keep
Yeah,
making a new
so
graph till you get connected, okay?
correct. For not big values, this works. So there are two ways, just so you know, knowledge is power. That's great, yeah. But power is also power. Not working. What's the problem?
Is there a problem or it just can't generate a connected graph?
Looks that it
Yes, it just
cannot.
takes time to create a.
Okay, nice. Uh, AR. Okay, looks better. Next.
So what do we want to do now? To simulate the spreading or?
No, we are supposed to find out. Um, Actually, we're supposed to solve the problem. The community counts for you to help to understand what is the worst case scenario, the outbreak, if no control measures are placed. So what's the most number of people to get infected? Write a Python program to model the spreading process. Given any third infected person, calculate the final number among the community. For example, if the first infected person is 1, then it should stop spread immediately. And after this 3 person are infected, then end up the spread. What is the highest number of infected person? Let's use this graph as how to say. Yeah, okay. Let's have something like this. No. Okay. And then just graph to numpy matrix and do not forget um, edge label. Okay, adjacent to matrix function. However, only the weights. What is the weight? I want the weight to be how it's called, mm, to be associated with the node color. Mm. Okay. That's okay. That's better. Okay, show me what you have. Okay, good. That's not working. Uh, hmm.
I mean, can you do it with unweighted graph, or it has to have?
Yes, of course I can. So do you understand what I'm doing?
Yeah, you're trying to get the form of that graph.
Yeah, I'm trying
Is
to.
there
Okay,
another way to save it, or I don't know?
okay, no
What is the
problem. No.
file?
Yeah. So I'm just trying to move it to some. Uh, okay, that works. Hmm. Okay, very good, very good. So I believe there should be some neighbors or ages. Maybe it just is called as ages.
Maybe G dot edges or something like that, not G dot node.
How to get a list of edges from. Ah,
Yeah, it's what I said.
yes, exactly. That's right. Okay, sounds good. Okay, now we have the nodes, the ages, and the fact of infected. Okay, now let's, how can we, okay, let's do the modeling. Let's do this, for example, Do experiments here. Get a random node that is not 1 or 3. How to do it?
How to get a
How?
random node or how to simulate the process?
What should I do? Oh, sorry.
Just generate a new random number, I mean.
Okay. Mm, I believe something like this. $21, 15, 27. Okay, let's color it.
Nice.
Nice. Okay. What's next?
Okay, now we want to simulate or something before
Yes.
that.
Yes.
Yeah.
Yes. Okay.
So I guess we can do something similar to BFS.
Okay. Okay.
I mean, we can just we can visit the node, and the first time we visit it, we can mark it that we visited it once.
Do you
And
know the BFS algorithm?
you ask me or
Yes. Yeah.
the
Oh,
other?
yeah. Yeah.
Yeah, I mean, I know it. It's something.
Why do we need deck in BFS?
Why do we need what?
Deck.
What's the deck? You mean queue
Deck.
or?
DQ. Yeah. Okay.
Oh, we need. I don't know why DQ. We need just the queue, the normal queue.
To keep track of the
Yeah.
order.
Not. Yeah. and so it's just simpler. You see? Double-ended queue. So you can push into the queue and you can pop. So there is pop left and this is push right. So push is actually push right. So append is push right. And pop left is take from the first.
Yeah.
Does make sense? Okay, very good. Okay, so when you're using BFS, so this is a good idea to use deck. Okay. By the way, what do we do on the simulation step?
Okay,
How?
so first we visit one node.
One node.
No, I mean, we are visiting nodes. And when we go to some node, we mark it that we visited it the first time. And then
Yeah, I'm
when we
asking what.
visited,
So we need to simulate the infections. How
yeah.
many nodes get infected? So we are going through nodes, and if we find, so two if two of node neighbors are infected and the node is not infected.
Okay, but I guess if we do that for all node in every cycle, it's too slow.
How can we make it faster?
I already said with BFS.
BFS. So what should we start with?
Okay, so we have those three nodes in the queue. Uh,
Next.
uh,
Okay.
then we will go through all the neighbors with those nodes of those nodes. So we are going through all the neighbors. And we mark the neighbor when we first visit it and mark it as infected the second time we visit it and then push it into queue.
Okay, so the problem is that there should be, how to say, not how to say, to get infected, the node should has two infected neighbors. For example, if this node is not infected and it has only one infected neighbor, it doesn't get infected.
Yeah, as I said, we mark we mark it the first time we visit it. And then
Okay.
we mark it as infected the second time we visited.
So if we mark it, if it is visited, then we mark it, or what? So what should we do?
The first time we visited, we mark it, I don't know, that we
-1.
visited it the first time. And the second time we mark it as infected and add it to queue. I mean, we are gonna have those only infected ones in the queue.
Okay. Okay.
And
Okay,
here,
guys. By the way, we're out of time for now. Should I give you this notebook, or you can write down it by yourself? I believe you can.
yep.
Okay, please use this important guy, I mean ChatGPT. So if there is a possibility to use it, so it will give you the answer in a minute or even faster. So please get practice with this. Okay, so for the next lesson, please do the previous topic with the game of life, and please do this. This is a problem for A. Okay. So the problem for A, and then we will get forward to the vaccination and then some machine learning. So this is actually not a machine learning, it's just a linear regression, but this is a very small machine learning. Okay. So instead of linear regression, use any machine learning. By the way, what machine learning models do you know except linear regression? So how do you think? What is the good model for here? Linear regression model is just, okay, so for example, I don't know what is linear regression.
I guess you're just gonna approximate the linear function. I mean, you know it. Why I'm saying this. Why no math?
Because it's boring.
No, it's not
Plus,
boring. The math is the most
minus.
interesting part of this.
I agree with that.
Okay, okay. Let's stop. Okay, okay. Give me code on matplotlib for this. For example, this. Okay, so by the way, when you are doing linear regression, there is a good way to evaluate this linear regression, right? So whether it is good, bad, or very bad. Okay, it works. Come on, I like greed. GRID. Okay, good. I want.
Could we use something
Yeah.
for evaluating linear regression, like those like mean, absolute error, and stuff like that?
There is R squared. There is
Yeah. Okay.
so it well, I asked it, is this linear regression good or bad? Okay, and this guy trying to explain me. So there's a p-value confidence interval. This is very deep statistics. There is, so actually, usually for linear regression, R square is good. So it depends on the variance that is predictable from the independent variance. Um, okay, simple. R squared close to 1 indicates a good fit. On your linear regression example, I want to calculate R2 score and put it into the title of the graph. Do it. Draw a picture. Give me code. Okay, here it is. Model score. So model score, it's actually how good the model is. Here you are. You see? By the way, how can I let me do this a little bit better. Okay, something like this. Okay, let me do the independent variable less. You see 0.89. Okay, if I do this, you see 0.99. That makes sense? Or if I do it 3, it will be bad. 87. This is not a linear regression. This is just a random red line. Okay, anyway, so it would be great if you read this problem and you can do this stuff with the, well, actually, if you can do number 1.2, so please do it. This is an absolutely real problem from the previous year. So if you solve this problem, you can probably get some points. What is the better cope with the situation? The sit and why? Okay, yeah. So, and if you do this and if you are good, so we can talk about other machine learning models. First of all, we can talk about regression. So there could be linear regression, could be non-linear regressions. Out of the non-linear regressions, there's an important thing of the polynomial regression and the logistic regression. Oh, and you can also, what is logistic regression? Give me code and explain and use this guy. It usually helps. So it's about true, false, 0, 1. Okay, machine learning. Okay, so if you can read it, then you're good. Okay, guys, so for the next lesson, please, first of all, do the homework from the previous lesson. I mean, this red and blue warriors on the game of life. Second, do this problem 1.2. And on the next lesson, it will be probably not me, but Andrei. So it will be not Alexei, but Andrei, another guy. So they will be working on this topic and further. Okay, please, questions. So we look down for today.
Okay,
Hello?
thank you very much.
Yeah.
I hope that your audience will give some feedback on today's meeting. I mean, it
That would be
seems
great.
quite interesting to me, though I wasn't very attentive, and I'm not sure. I'm not sure if they understood everything or not.
That's okay.
They're
That's
smarter
totally
than
okay.
me. They're
Yeah, I
smarter
will
than
not be
me. So,
sharing this notebook because I hope you can do it yourself. So if you
may I suggest
can,
that we still share this notebook with them, because I'm not sure that they will have
okay, no
time,
problem.
and if they don't do it, then they will
Graphs,
be
I
able
don't
to.
know, exercise, graph exercise. Okay, so this is graphs exercise, and we are okay, so let me share it with you. Okay, let me do it later. Okay, so let me share this notebook with you. with you, and you can share it with everyone. Okay.
Yes, I can forward it to
Please.
our chat. Okay, thank you
Good.
very much. Guys, if
So
any questions,
I'm not sure about next week, guys, because next week I will be out of. I will be not here in California, so probably it will be not me. Okay.
you won't be yourself next week. Okay, we got it.
I will be myself, but I will be not here. I will be located in a different place of the West Coast. So I would probably be going to this to some warm place, because today is I don't know, plus 50 degrees Fahrenheit. I mean, okay, it is 10 degrees of Celsius. Well, so 50 is cold. Yeah.
Okay, thank you
Okay.
all for coming. Then
Yep.
I suppose that we're done for today.
Yep. See you.
Bye.
Bye.
Bye.